Hi guys, this video is going to review the 3 laws of exponents that we've learned so far and then go over a couple more examples that we haven't gotten to yet. So we've learned 3 of them. Here they are listed, but you're going to want to take notes as you watch this. All right, so here are the 3 laws of exponents that we have learned, and I'm going to do an example of each of these, so you guys might want to pause, write these down quick, and then we'll do them together. Okay, if you guys take a look at the first one. All right, you might notice that it's all multiplying. So we're going to use our product of powers rule. Okay, when you're doing this, it doesn't matter the order you multiply in. So I like to multiply my normal numbers first. Again, you can go in any order when you multiply, and then I multiply my exponents. Okay, I just kind of shaded those for us. So if I multiply my normal numbers, 3 times 5 is 15, times 2 is 30. Okay, so those are just normal numbers. We just multiply them like normal. Okay, use those. All right, now x squared times x to the 4th. Remember, if you are having a hard time remembering the rule, you can write it out the long way. So x squared is the same as x times x. X to the 4th is x times x times x times x. That's the same as x to the 6th. So my final simplified answer is 30 times x to the 6th. You do not have to put a dot in between there. You can just leave it right next to each other because that means multiplied. Now, hopefully you remember the rule when you're doing this is you can actually add those together and get x to the 6th. All right, the second one is a product or a power to a power rule because it's taking everything in this parentheses and cubing it. So if you guys look at this one, we need to cube everything inside here. So we need to take 5 to the 3rd and cube it. So power to a power rule, you can multiply. So it ends up being 5 to the 9th power. If I do x to the 4th and I cube that, that'd be like if I did x to the 4th, and I did that 3 times. Okay, so hopefully you guys could kind of figure that out. That would be x to the 12th. So you multiply, and then m squared, if you cube that, that's m to the 6th. So this would be my final simplified answer. All right, my last rule is the quotient rule. Okay, I'm going to write this one out the long way. Okay, so x to the 6th. I'm going to write x times x times x times x times x 6 times, and then y to the 5th. 1, 2, 3, 4, 5. Okay, on the bottom, I'm going to write x squared and then y to the 3rd. Okay, now when I do this one, I like to use this method, but I'm going to simplify some x's. So x divided by x, that's a 1. This x divided by that x, that's a 1. This y and this y, if you divide that out, it's a 1. That's a 1, and that's a 1. So now let's see what I have left. I'm just going to switch colors here real quick. Looks like I have on the top x to the 4th. And then up here, I also have y squared. On the bottom, those are all just 1s. So over 1, you don't have to write. You can just leave it like that. So my final answer is x to the 4th y squared. That is not a fraction. It's just, if you wanted, you could put 1 on the bottom. But that would be my final answer for that one. All right, these next 2 are ones that were not gone over in the last video, and they deal with the quotient rule. So I want you guys to copy these 2 down real quick. Okay, on ones like this, I didn't show you guys this yet, but when you have normal numbers out front, you still just divide it just like normal. So here's kind of what I usually do on these. I look at those 2 normal numbers, so the 10 and the 20. Okay, as you look at that 10 and the 20, I want to try to find, is there something that I can divide out of both? So what number goes into both 10 and 20? Well, 10 does. So I think to myself, what's 10 divided by 10? It's 1. I cross it off, put a 1. 20 divided by 10 is 2. Okay, so now you guys can either use the law of exponents, or right now I have a 1 and a 2, and then I have x to the 8th. 4, 5, 6, 7, 8 x's, and then x squared on the bottom. Okay, now we can simplify that. We can simplify this x and that x, that x and that x. Remember, those just make 1s. Okay, so my final answer, well, 1 times 1 times 1, that's just 1. And then x times x times x times x times x times x is 1, 2, 3, x to the 6th. On the bottom, I have 2 times 1 times 1. Remember, we're not adding. This is times when they're right next to each other, which is 2. So my final answer is x to the 6th over 2. Now, again, you could have used the law of exponent rule. You could have subtracted the bottom from it and got x to the 6th on the top, which I did. So right here, I could have got that, and then just did my normal division and got the 2 on the bottom. Okay, let's try the next one. Okay, so same thing. I'm going to look at my normal numbers first. These do not have exponents with them. Since they don't have exponents, I just need to divide them like normal. So what's a number that goes into 15 and 10? Well, 5 does. 15 divided by 5 is 3. 10 divided by 5 is 2. Okay, so now I've got my 3 on the top, and then I also have it times x to the 4th. On the bottom I have my 2, and then x to the 3rd. Okay, now I'm going to simplify. X divided by x is 1, x divided by x is 1, x divided by x is 1. So those are just a bunch of ones. So on the top, 3 times 1 times x is just 3x. On the bottom, I just have a 2 times 1 times 1 times 1 is just 2. So my final answer is 3x over 2. You could put an x to the first power there. That would be fine as well. All right, hey guys, we are going to look at a couple problems to see if they did these correct. So what I want you guys to do, we're not going to look at the bottom two. Let's just look at the top 3. I want to know, are these correct? Did they do them correctly? Yes or no, and why? So I want you to pause the video and try them. And then when you are done, you can push play. Okay, let's look at the first one. Okay, first thing I notice about these is they all have the same base, a third, a third, a third. Then I can use the laws of exponents. Now the first one says a third squared, so that would be like a third times a third times a third to the 4th. So a third times a third times a third times a third. Okay, I end up having 1, 2, 3, 4, 5, 6 of those, so that is the same as a third to the 6th. So yes, they did the first one correctly. All right, second one. Okay, first thing I notice about these ones, if you look at this, it says 3 squared and 5 to the 3rd. Okay, first thing that is super important. If they do not have the same base, you cannot use the laws of exponents. So I cannot combine these anyway. They just have to stay separate. I can't do anything with it. They don't have the same base, so I cannot use any tricks. So when they did 15 to the 5th, they added these. You can't do that. And you can't just times those numbers either. You cannot put them together. So the answer to that is no. Okay, third one. If you guys take a look at this one, you might notice, oh, good, they have the same base, 5, 5, 5. Awesome. Okay, and then you might say, okay, well, they have 4 and 5 here, so I'm just going to add those together. Okay, they get 9. Now, you cannot do that because we haven't seen this yet. There's a plus in between here. That does not work. We've only done rules where it was timesing or dividing. Okay, so if it's this, if you actually work this out, 5 to the 4th, I'll just do it real quick. So if you're ever not sure, just test it. So 5 to the 4th, I just typed that in on my calculator. I got 625. Plus, if I do 5 to the 5th, again, I'm just going to type that in on my calculator. I get 3,125. And if I do 5 to the 9th, I get 1953125, real big number. Now, if I add these two numbers together, that is not going to equal this number. So again, you cannot do it if it's plus. You cannot combine those. All right, last little bit that we haven't seen ones like this either. We're going to put everything kind of together. So if I was doing this first one, I'm just going to rewrite the top as 2 to the 5th. Now on the bottom, I need to use my power to a power rule where I can multiply. So 2 squared to the 5th power, 2 times 5 is actually 10. So I'd end up with 2 to the 10th. Okay, so now if I was thinking about this, if I was going to write it out kind of the long way, it would end up being 2 to the 5th, 5 of those, and then 10 of them down here. So think about it. The 5 would cancel 5 of them on the bottom. So I'm left with on the top. Please do not write a 0 on the top. These are all 1s. 1 times 1 times 1 times 1 is 1. On the bottom, I would end up with 2 to the 5th. So my final answer is 1 over 2 to the 5th for that first one. Okay, or if you use the laws of exponents and you subtract 5 from 10, 5 minus 10, you might end up with 2 to the negative 5. We are going to learn what that means actually in tomorrow's lesson, but that's actually the same as this. Okay, let's look at the next one. Okay, on the top, power to a power, I get 6 to the 15th. On the bottom, I see the same base, so I can add these. 12 and 6 gives me 6 to the 18th. Okay, so now I could maybe use my laws of exponents. Some of you might say, okay, just subtract the 15 minus 18. I end up with 6 to the negative 3. Okay, that is technically the right answer. We're going to learn how to simplify that tomorrow. Or if I had all those, if I had 15 6s up here and 18 down here, just imagine 18. These 15 are going to cancel with 15 of these. I'm going to be left with 3 on the bottom and just a 1 on the top. So that's the same as 1 over 6 to the 3rd. Okay, so either of those answers would be fine as well. So tomorrow we're going to learn more about negative exponents, and we'll show you some more tricks even. If you have any questions, please let your teacher know. Have a good day.